Welcome to educator.com. This lesson is about equivalent fractions. In this lesson, you will learn to find equivalent forms of fractions, and applications for this are to describe parts of the whole or to make working with fractions easier. For example, when you need to add and subtract fractions. Vocabulary for this lesson is equivalent fractions. In the word equivalent fractions, you can kind of see the word equal here. And that's exactly what it means, fractions that are equal. So for example, 2/3 is equal to 4/6. So if you say 2 times 2 and 3 times 2, you're multiplying the top and bottom by the same number, so you create an equivalent fraction. And in fact, when you're multiplying the top and bottom by the same number, in essence, you're multiplying by 2 over 2, which we know equals 1. And the identity property tells us that when you multiply any number by 1, you get the same number back. So 2 over 3 is the same number or an equivalent fraction to 4/6, just having it look a little different. Our next vocabulary word is simplest form. Simplest form of a fraction occurs when you can no longer divide the numerator or denominator by any other factors except for 1. For example, 5 over 10 is not the simplest form of a fraction because 5 and 10 both share a factor of 5. 5 divided by 5 is 1 and 10 divided by 5 is 2. At this point, 1 over 2 is the simplest form because 1 over 2 can only be each divided by the number 1. So 1 and 2 are prime with respect to each other. Creating equivalent fractions, as we just spoke about, means to multiply the top and the bottom, the numerator and the denominator, by the same number, or to divide the numerator and the denominator by the same number. And the number should be not 0. So let's try writing some equivalent fractions. Write 2 fractions equivalent to 5/8. 5 over 8 is already in simplest form. So we had 2 options of multiplying or dividing, but in this case I can't divide anymore, so I'm going to multiply. You can really multiply by any number you want, anything from 2 up to infinity. So I'm going to take 2 because that's simpler. 5 times 2 is 10 and 8 times 2 is 16. You could also do times 3. 5 times 3 is 15 and 8 times 3 is 24. So I have created 2 equivalent fractions to 5 over 8, 10 over 16 and 15 over 24. Write 2 fractions equivalent to 2 over 14. Well, 2 over 14 can be simplified. So in this case, I can also divide to create an equivalent fraction. I'm going to divide the top and the bottom by 2. 2 divided by 2 is 1. 14 divided by 2 is 7. So I've created one equivalent fraction, 1 over 7, by dividing. And now I'm going to create one by multiplying. And this time, take a different number, 10. 2 times 10 is 20. And 14 times 10 is 140. So here I've created 2 equivalent fractions. One I created by dividing and one I created by multiplying. We're going to be using GCD, or the greatest common divisor, to simplify fractions. We learned about finding GCD in a previous lesson, so if you don't remember how to do this, you could review that lesson. We're going to take 24 over 32 and find the factor trees of each. That way we can see which factors the 2 numbers have in common. 4 times 6, 2 times 2, and 2 times 3. Here we have 4 times 8, 2 times 2, 2 times 4, 2 times 2, 2, 2, and 2. So I see here they share a 2, and another 2. So 2 times 2 times 2 is 8. So I know that 24 and 32 share the greatest common divisor of 8. So I can divide both the top and the bottom by 8, giving me 3 over 4. So the simplest form of 24 over 32 is 3 over 4. Let's find, so that's what we just did. We found the GCD of 24 and 32. And now let's try another example. This one has a negative, negative 27 over 45. So we know my answer, or our answer is going to have a negative, but besides writing the negative into the answer, we can now not think about it anymore and just do our factor trees. 3 times 9, and 3 times 3, and 3. 5 times 9, 3 times 3, and 5. So here we see they share a factor of 3, and 3, 3, and 3. 3 times 3 equals 9. So the top and the bottom share a factor of 9. 27 divided by 9 is 3, and 45 divided by 9 is 5. So the simplest form of negative 27 over 45 is negative 3 over 5. Writing a fraction. Remember that the numerator represents the part and that the denominator represents the whole. In a parking lot, 32 of the 96 vehicles are trucks. In the simplest form, what fraction of the vehicles are trucks? So we have 32 over 96. So I'm going to find the GCD of 32 and 96. This is going to be 4 times 8, 2 times 2, 2 times 4, 2 times 2, 2, 2, and 2. Here I have 8 times 9, and I can already see that there's going to be an 8 here and an 8 here. So I'm going to use 8 as my GCD. Oh, this is going to be, 8 times 12. Oh, so in fact, there will be more factors. So let's not say we're going to use this 8 yet. I'm going to take off this here. Let's keep factoring. 2 times 4, 3 times 4, 2 times 2, 2, 3, and 2 times 2. So we share 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay, so the top can be divided by 32 and the bottom can be divided by 32 because all of the factors equal the top number here. 32 divided by 32 is 1, and 96 divided by 32 is 3. So in simplest form, a third of the vehicles are trucks. So once again, let's try writing a fraction. Remember that the numerator represents the part and the denominator represents the whole. On an airplane, 45 out of 130 seats are empty. In simplest form, what fraction of the seats are empty? So let's take 45 and 130. 5 times 9, 5, and 3 times 3. Here we have divide by 5, 130, goes into twice, and goes in 6 times. So 5 times 26. 26 can be divided into 2 times 13. So they share a factor of 5. So I'm going to divide the top by 5 and the bottom by 5. 45 divided by 5 is 9, and 130 divided by 5 is 26. So in simplest form, the fraction of the seats that are empty are 9 out of 26. Marge ordered an extra large party pizza with 32 slices. If 4 slices are left, write in simplest form the fraction of the pizza that's left over. So there's 4 out of 32 slices left. 4 can be divided by 4, as can 32. 4 divided by 4 is 1, and 32 divided by 4 is 8. So in simplest form, an eighth or 1/8 of the pizza is left over. 2 different websites describe the driving time between 2 cities. One website says the driving time is 45, and the other says the driving time is 3/4. How can the websites be describing the same amount of time? Well, let's think about how time is described. It could be 45 minutes or 3/4 of an hour. So we know that an hour is 60 minutes. So if you take 3/4 of 60 minutes, 3 times 60 is 180 over 4. And we can take 180 and divide by 4. This will go in 4 times. And lastly, 4 will go into 25 times perfectly. So there's the 45 and the 45. So it's very important when completing a word problem that you indicate your units. In this case, 45 minutes, the first website is talking about, and in the second case, it's talking about 3/4 of an hour. Write 40 over 50 in simplest form. If you remember your divisibility rules, you'll see that both 40 and 50 can be divided by 10. 40 divided by 10 is 4, and 50 divided by 10 is 5. So in simplest form, 40 over 50 is 4 over 5. Over the last 3 seasons, a school basketball team has won 25 out of 35 games. In simplest form, write the fraction of the games the team has won. So 25 wins out of 35. The top and bottom can be divided by 5. 25 divided by 5 is 5, and 35 divided by 5 is 7. So in simplest form, the school basketball team has won 5/7 of its games. Thank you for watching educator.com.